Good morning, chemistry students. Here are your Chapter 6, Day 3 notes. This is going to be all of Chapter 6, Section 3. And this section is about ions, specifically monatomic and polyatomic ions. You are definitely going to want to have your helper sheet out, and you're going to want to have your periodic table out. We're going to talk about how to use our periodic table and our helper sheet to figure out the charges on ions. And we're also going to talk about how to name all of those ions. So the title of this section is Ionic Charges, and we're going to start by talking about monatomic ions. Remember, monatomic means one atom. So monatomic ions are going to be ions that are formed of a single atom. So to write the chemical formulas for ionic compounds, you must know the ions atoms tend to form. Which means you have to know their ionic charges. So, monatomic ions are ions consisting of only one atom. And for these, for the most part, you will use the periodic table. The charges that these monatomic ions have relates to getting 8 valence electrons, like the noble gases. If this atom decides or is going to lose electrons to become an ion, remember that means it's going to be positively charged. The atoms that tend to do this are the metals. Remember, the metals are to the left and below the heavy stair-step line on your periodic table. To name these ions, it is just the element name plus the word ion. When the metals in groups 1A, 2A, and 3A lose electrons, they form cations with positive charges equal to their group number. So we're going to take a look at a periodic table, right? Here's our periodic table. And we're talking about cations, and remember, kind of here's our dividing line, right? Okay. And again, remember, this way and this way are our metals. Typically, the metals are going to form the cations. Remember, these also are metals. Okay. So, what we're talking about here is getting 8 valence electrons. So remember, these A numbers are telling you how many valence electrons each of these groups has. Okay, so we have 1 valence electron in group 1A, 2 valence electrons in group 2A, 3 valence electrons in group 3A, and we're really talking about the metals here. So we're going to kind of ignore the rest of them, right, because they're more non-metals. These guys are kind of over in here. These guys act more like these group B ones, which we're going to talk about in a couple minutes, okay? So our question always is, we want 8 valence electrons. That's what we're trying to get. Okay, so the question that we have to ask when we're in group 1A is, are we going to lose that 1, okay, or are we going to gain 7? And they're always going to do whatever's smallest, so they're going to lose 1 electron. And when these guys lose 1 electron, they're going to get a charge of +1. In group 2A, the choices are, we can lose these 2 electrons, okay, or we can gain 6. Again, they're always going to do what's easier. They're going to lose those 2. These are going to have a charge of +2. Group 3A, which pretty much is just boron and aluminum, they have 3 valence electrons. So they can either lose those 3 or they can gain 5. They're going to lose those 3, so they're going to have a charge of +3. So we can use our periodic table to figure this out. Okay? And that's what I was kind of talking about here, about using our periodic table. All right? I just showed you how to use your periodic table. However, you also, okay, can use this idea, which is when the metals in group 1A lose, they form a positive charge equal to their group number. So group 1A has a charge of +1, group 2A +2, group 3A +3. I don't care which way. Whatever works best for you is fine with me. What's important is that you know that the elements in group 1A have a charge of +1, group 2A +2, and group 3A +3. If you do that by figuring out how many electrons they have to gain or lose to become valence electrons, that's perfectly fine, okay? But you have to be able to look at a periodic table and know this. Okay, this is not information that I'm going to give you. I expect you to be able to use your periodic table to determine this and to figure this out. Okay, so you'll always get to use a periodic table, but you have to be able to figure that out with a periodic table. So I want to take a look at a couple examples. For these examples, what I would like you to do is to figure out what charge they have and to name them. So when magnesium becomes an ion, when sodium becomes an ion, and when aluminum becomes an ion, what charge do they get? So what's their charge? And how do we name them? So again, if you need more time than I give you on the video, then you should just go ahead and pause the video at this point and use your periodic table and figure this out. So when I find magnesium on my periodic table, it's right here. It's in group 2A, so it has 2 valence electrons. So it can either lose those 2 or gain 6. It's going to lose 2, so it's going to have a charge of +2. And its name is going to be magnesium ion. All right, sodium. Sodium is right here. It's in group 1A, which means it has one valence electron. So it can either lose that one or gain 7. It's going to lose 1, so it's going to get a charge of positive 1. And its name as an ion is going to be sodium ion. So aluminum. Aluminum's right here on my periodic table. It's in group 3A, which means it has 3 valence electrons. So it can lose 3 or gain 5. It's going to lose 3, therefore it has a charge of positive 3. And its name as an ion is aluminum ion. So those were our cations. We don't always lose electrons though. Remember, sometimes we will gain electrons, in which case our ion is going to have a negative charge. Remember, the elements that do this are the nonmetals. Again, our nonmetals, okay, we talked about this just a moment ago, but to remind you again, right, our nonmetals are right over here, right? They're on the right side of our periodic table, above and to the right of that heavy stair-step line that's on your periodic table. Okay, so it's the nonmetals that tend to gain electrons. In terms of naming these monatomic ions, we're going to take the element name. It's going to lose its ending. So you're going to remove its ending, and then you're going to add "ide." For these, the charge of any ion of a group A nonmetal, and group A just means, remember, we're talking about tall columns on the periodic table, is determined I wanted to see how much more room I had, is determined by subtracting eight from the group number. Oh, I don't know when it stopped again. I'm sorry, you guys. Just I'll recap, right? To write formulas for ionic compounds, we have to know charges on ions. Monatomic ions, you need to be able to use your periodic table. It relates to getting 8 valence electrons like the noble gases. For the cations that lose electrons and get a positive charge, typically those are the metals. To name them, it's the element name plus the word ion. When the metals in group 1A, 2A, and 3A lose electrons, they form cations with positive charge equal to their group number. So again, what that was saying was, okay, that I can think of it a couple different ways. Group 1A has 1 valence electron, lose 1 or gain 7, gets a +1 charge. Group 2A, okay, right here, 2 valence electrons, it can lose those 2 or gain 6. It's going to lose 2, so it has a charge of +2. Group 3A, which is pretty much boron and aluminum, the choice is to lose those 3 or gain 5. It has a charge of +3. Okay, so that's what we were kind of had talked about, and like I said, I don't know when I stopped recording. So these 3 examples we did, right? Magnesium ion. Magnesium is in group 2A. It has 2 valence electrons, so it's easier to lose 2 than to gain 6. So it has a charge of +2 and is called magnesium ion. For sodium, it's in group 1A. It has 1 valence electron. It's easier to lose 1 than to gain 7. So it has a charge of +1 and is called sodium ion. And for aluminum, it has 3 valence electrons. So it's easier to lose 3 than it is to gain 5. It has a charge of +3 and is called aluminum ion. So those were the cations. For the anions, when they gain electrons and they get a negative charge, remember this is going to happen with the nonmetals. And again, this is kind of our dividing line between metals and nonmetals. Metals are this way. Nonmetals are over here. Okay. You should know that because we've talked about that before. That was back in chapter 5 where we talked about metals and nonmetals and that type of thing. Okay. So for the nonmetals, to name them, we take our element name, it loses its ending, and it gets the ending "ide." And the other way that we can think about this, rather than just thinking about do we gain or lose electrons to get 8, is that you can actually take the element group number and subtract 8 to figure out its charge. So when we look at fluorine, okay, that's in group 7A, it can either lose those 7 or gain 1 electron. It's always going to do whatever's smaller, which is gain 1, so it has a charge of -1, and it is named fluoride. So looking at oxygen, oxygen is right here. It has 6 valence electrons, so its choices are it can lose those 6 or it can gain 2. It's going to do whatever's smaller, so it's going to gain 2. It's going to gain 2 negative charges, which gives it a -2 charge. And in terms of naming it, it's oxygen. It loses its ending and it becomes oxide. Lastly, taking a look at our nitrogen example. Nitrogen is right here on our periodic table. It's in group 5A. So it has 5 valence electrons. So is it easier to lose those 5 or gain 3? It's easier for it to gain 3. So its charge is -3. And its name, nitrogen, it's going to lose its ending and become nitride. So, remember group A, we're talking about tall columns on the periodic table. And so what I expect for the group A, the tall columns on the periodic table, is that group 1 has a charge of +1, group 2 a charge of +2, group 3A a charge of +3, group 5A a charge of -3, group 6 a group charge of -2, and group 7A a charge of -1. If you get there by figuring out how many valence electrons and is it easier to gain or lose, that's fine. Okay? Tall columns of the periodic table, the group A elements, you should be able to use a periodic table to figure out the charge on the ion. That is not the case when we start to talk about these group B, which also kind of includes some of these underneath here. Okay? They do not follow a predictable pattern. All right? So that's what we're going to be talking about next, are these short columns on the periodic table, okay? And the fact that they don't tend to follow a predictable pattern. So, again, there's going to have to be something a little bit different for figuring out their charges. So, for the group B metals, they often have more than one charge. Which is what makes them more complicated. For the tall columns that we've just been talking about, they only ever have one possible charge. But when we get into those short columns and underneath that heavy stair-step line, the inner transition metals, they sometimes have more than one possible charge. This information will be provided So it's on your helper sheet, which you got today, or you should be able to print today. To find it to print, it's in the general class resources, and it's called Periodic Table and Helper Sheets. I would really recommend that you find a way to print that information. The charges of the cations of many transition metals, and again, transition is just the name for the short columns on our periodic table, ions must be determined from the number of electrons lost. So what that means is that sometimes your textbook might say, what charge does a copper ion has when copper atom loses one electron? Well, if you lose one electron, you're going to have a positive 1 charge. Okay, I also give you this information on the helper sheet. So this is a picture of the portion of the helper sheet that relates to this. This is that transition element needed information. And so I want to talk for a minute about how to read this. Okay, so first off, right, our first column is just the element, right? And notice I gave you the name, not their symbols. This is your helper sheet. You certainly could go and write on it and write symbols, so that maybe that would be a little easier for you, okay, but I've given you the name. This middle column is telling you, because these transition metals, many of them have more than one possible charge, this middle column is telling you the possible charges. So what this is saying is that there's a copper ion that exists with a +1 charge, and there's a copper ion that exists with a +2 charge. Okay, now with this one here, this one people always ask about, right? This is pretty much on the left. This is a mercury with a +1 charge, and this is a mercury with a +2. Okay, because this is Hg2, so there's 2 mercury ions having a charge of +2, which means each mercury ion has a charge of +1. Okay, so again, what this means is that there's a platinum charge with a +2 and a platinum charge with a +4. Okay, so I'm telling you these different charges they could have. Over here, because one of our naming systems that we're going to talk about here in just a few minutes uses Latin roots, I've given you the Latin roots. Now, what is kind of important to notice here is that there are, right, these 4 down here at the bottom that do not have more than one possible charge. So these, okay, down here only have one possible charge. They're more like our tall columns of our periodic table where we can only have one possible charge. Okay, so you don't have to memorize this information. I give you this information on your helper sheet as part of what I provide you with your periodic table. Okay, so because these group B metals have more than one possible charge, it's a little bit more complicated to name them, because somehow we have to communicate which copper ion we mean, the copper with a +1 charge or the copper with a +2 charge, okay? So that changes a little bit how we have to name these. Now, for these 2 naming methods, we only use this if, okay, the metal has more than one possible charge. Okay, so what that means is, that's why I pointed out these down here. For these, I don't have to use this because silver, cadmium, zinc, and scandium only ever have one possible charge. And any chemist is going to know that. So if you have a silver ion in something, a chemist is always going to know it's a silver with a +1 charge. I don't have to tell them which one it is the way I do with these up on the top. Okay? So for ones that have only one possible charge, they're just like these that we talked about. We just name them. Silver ion is just silver ion. Cadmium is just cadmium ion. We just use element name plus the word ion because they only have one possible charge. So the two naming systems, the first system is called the stock system. In the stock system, the charge on the ion is equal to a Roman numeral so when you name these, okay, it's going to be the metal name, and then a Roman numeral, and then the word ion. Now, in case you're not sure about Roman numerals, right? I is 1. 2 I's is 2. 3 I's is 3. IV is 4. And let's double check, but I think that's the largest. Oh, we've got one with a +5. So, oops, sorry. So a V is a 5. Okay. So those are the Roman numerals in case you're not very familiar with Roman numerals. Okay. So we take our metal name, Roman numeral, and then the ion. So if, for example, I asked you to name Pb with a +2 charge. So I look at my periodic table because I need to know who Pb is, and Pb is lead. So my metal name is lead. Because it has a +2 charge, I'm going to use the Roman numeral 2. Okay. Sorry. Let me move where I'm putting this. Lead, 2, and then the word ion. So in the stock system, I don't really necessarily have to use my helper sheet a lot because this charge on my ion becomes my Roman numeral. So that is how you name these with the stock system. The other system is called the classical system. Now, while you write that down, why do I teach you both? Because depending upon where you go to college, if you take a college chemistry class, you might have a professor that names things using the stock system. You might have a college professor who names things using the classical system. As a result, I'm going to ask in high school chemistry, with me as your teacher, that every single time you encounter something that can be named using both the stock and the classical, that you always name it both ways, just to practice using both systems. In the classical system, you're going to name these using the Latin root of the element plus an ending, right? And the proper English term for an ending is a suffix. Okay, so we're going to use that Latin root of the element plus the ending, which is why, again, on your helper sheet, you have those Latin roots. Not something you have to have memorized. It's right here on your helper sheet for you. Okay? Now, what are those endings? What are those suffixes? Okay. Us for the lower charged. Ion. And ick for the higher charged ion. Now, this is not mine. This is a student years and years ago who was struggling to remember which one was lower and which one was higher. So that student thought of it this way. She built a pyramid with it. And if you were building a pyramid with it, us would be on the bottom and it would be on the top, right? And so she remembered that us is on the bottom, so it's the lower charged ion. Ick is on the top, so it's the higher charged ion. Again, I'm just giving you that suggestion as a possible way to remember it. It wasn't my idea. It was a student long ago who was struggling on that. Okay? So if we looked at that same example that we did, we looked at the lead 2, right? So I need to first find lead and find its Latin root, which is plum. So this is going to be a plum. And now I need to see, is +2 the lower or higher charged? So I find my lead, and +2 is the lower charged of the two choices. So it's going to get the ending us. Okay, and we still add the word ion. So this is plumbus ion. So the other way to name lead 2 ion is to call it plumbus ion. All right. So my question for you is, which of these do you prefer and why? So I want you to think about that for a moment, okay? Do you like the stock system better? Do you like the classical system better? Which one do you prefer and why? And sort of, in my opinion, is a right answer. I really don't care what answer you had. But I would say that most people prefer the stock system. Because the charge on the ion becomes a Roman numeral. So I don't have to, right, if we go back and look at that example, right, when I say it's lead 2 ion, I don't have to look at my helper sheet. I look at my periodic table, I find my symbol for lead, it's Pb. The 2 is telling me it has a charge of +2. I don't have to look at my helper sheet to figure out what this is. Versus, right, plumbus ion. Now, maybe you've done this a while like I have, and you know that plum refers to lead. But if you don't know that, you're going to have to look at your helper sheet, figure out its lead. After you figure out its lead, you're going to have to remember it's plumbus, the lower charged one, and then it's a lead with a +2. So generally, most people prefer the stock system because it doesn't really require using our helper sheet. Again, remember, Mrs. K's expectation is that you always name ions, and this is even going to relate when we start to write the formula or the names for compounds, okay, with more than one possible charge using both the stock and classical systems. Okay, so I always expect you, if it has more than one possible charge, to name it twice. So that's all about monatomic ions. We're going to do a little practice here. Okay. And this is the last thing that needs to fit before you get to polyatomic ions. Okay. I want you to write the formula, which is what we were doing when we wrote it as Pb plus 2. Okay, that's what I mean by write the formula. And name these ions. And again, if they have more than one possible name, you should name them twice. So, selenium, barium, phosphorus, iodine, potassium, lead with 4 electrons lost, and sulfur. So that's the first part I want you to do. I also want you to say how many electrons were lost or gained to form these ions. And I want you specifically to use the words lost or gained, not plus or minus. So again, I'm going to give you a little bit of time here on the video, but if you need more time, right, the easy thing to do is just pause your video. Again, you probably need your helper sheet. You need your periodic table. So when you find selenium on your periodic table, its symbol is Se. So I'm going to go ahead and just write that because I'm going to need it to do my formula. Selenium is in group 6A. It has 6 valence electrons, so it can lose 6 or gain 2. It's going to gain 2, so it has a charge of -2, so there's my formula. And naming it, it's an anion, which means I'm going to take its element name, it's going to lose its ending and get "ide." So this is selenide. So barium is symbol Ba. Barium is in group 2A. That means it has 2 valence electrons. So it can lose 2 or gain 6. It's going to lose 2, so it gets a charge of +2. So there's my formula. Because it's a cation, I'm going to name it by taking my element name and adding the word ion. So this is barium ion. So phosphorus, right? Phosphorus is symbol P. It's in group 5A, so it has 5 valence electrons. So its choices are to lose 5 or gain 3. It's going to do whatever smaller, so it's going to gain 3, so it has a charge of -3. And because it's negatively charged, I'm going to take my element name. It's going to lose its ending and get the "ide." So this is phosphide. For iodine, iodine is symbol I. It's in group 7A, so it has 7 valence electrons. So it can lose 7 or gain 1. It's going to gain 1, so it has a charge of -1. Because it's negatively charged, it's going to lose its ending and get an "ide," so it's iodide. Sorry, I'm going to pause this for a second. I hear my dog, and I think she wants to go outside. All right, potassium, that is element symbol K. Potassium is in group 1A. It has 1 valence electron, so its choices are to lose that 1 or gain 7. It's going to lose that 1, so it gets a charge of +1. And because it's positively charged, remember, I'm going to name it with the element name and the word ion. And remember, because it's in a tall column of the periodic table, it only has 1 possible charge. So I don't have to worry about naming it twice. So it's potassium ion. Lead with 4 electrons lost. So I'm going to look for my symbol for lead. It's Pb. And it needs to kind of set off little alarm bells in my head when I find it, because it's underneath that heavy stair-step line, which means it could have more than 1 possible charge. So, because it's under that heavy stair-step line or in the short columns of the periodic table, I have to look at my helper sheet. And it's on my helper sheet, and it tells me here it has 4 electrons lost, which means it's going to have a charge of +4. So that's my symbol. But because it's on my helper sheet, and it has more than 1 possible charge, that means I have to name this twice. Once using the stock system, once using the classical system. So to do the stock system first, remember that's where I'm going to use the element name, a Roman numeral equal to the charge, and the word ion. So this is lead. My Roman numeral is IV, ion. So that's one of my names. Now I need to name it a second time. Now I have to probably use my helper sheet, right? So I'm looking at lead, right? The Latin root is plum, and I notice that +4 is my higher charged one. So plum. My ending when it's the higher charged one is ic, ion. So my other name for this is plumbic ion. Lastly, we have sulfur. Sulfur is element symbol S. Sulfur is in group 6A of my periodic table. That means my choices are it can lose those 6 or gain 2. It's going to gain 2, so it has a charge of -2. That makes it an anion, and remember to name that. I take my element name, it loses its ending, and gets "ide", so this is sulfide. So the last set of questions here, right, is how many electrons were lost or gained to form these ions. If Fe has a charge of +3, that means that it lost 3 electrons. If oxygen has a charge of -2, that means that it gained 2 electrons. If copper has a charge of +1, that means that it lost 1 electron. And if strontium has a charge of +2, that means that it lost 2 electrons. So the last thing we have to talk about are polyatomic ions. Now you have a helper sheet that has some polyatomic ions on it that you're memorizing. The definition of polyatomic ions is that they are tightly bound groups of atoms that behave as a unit and carry a charge. So with these polyatomic ions, you have the list of 10 that you are expected to memorize. Most of the polyatomic ions end in either -ite or -ate. There are a couple exceptions, and kind of 3 of them, and 2 of them are ones you have memorized, right? One of the exceptions is ammonium, which you have memorized, right? Ammonium is NH4 with a +1 charge. It's the only positively charged one I asked you to memorize. Another exception is cyanide, which you don't have to have memorized, but is here on your helper sheet. Right here, cyanide. It's CN with a charge of -1. And then hydroxide, which is one that you have memorized, which is OH with a -1 charge. So those are the only 3 of the polyatomic ions you're going to deal with that don't end in an -ite or an -ate. Ammonium, cyanide, and hydroxide. And again, ammonium hydroxide are both ones you have memorized. Cyanide's on your helper sheet. So we want to look then at what's the difference between -ite and -ate ions. So to kind of look at that, I'm going to give you some to look at, right? So SO3 with a charge of -2, this is sulfite. SO4, -2, is sulfate. NO2, -1, is nitrite. NO3, -1, is nitrate. ClO2 negative is chlorite. ClO3 negative is chlorate. So we kind of, again, want to look at like that. What's the same? What's different? So between a sulfite and a sulfate, what stays the same? What's different? Between a nitrite and a nitrate, what stays the same? What's different? Between a chlorite and a chlorate, what stays the same? What's different? So notice what stays the same, right? I have the same elements, right? Every single time. Sulfur, oxygen, nitrogen, oxygen, nitrogen, oxygen, chlorine, oxygen, chlorine, oxygen. So in each of these, I had the same elements. Also notice the charges stay the same. Right? Nitrite, charge of -1. Nitrate, charge of -1. Chloride, charge of -1. Chlorate, charge of -1. Okay? So the ite and the ate always have the same elements. They have the same charges. What's different then? Okay? So what do we see being different? 3 oxygens, 4 oxygens. 2 oxygens, 3 oxygens. 2 oxygens, 3 oxygen. So what's different? The amount of oxygen. And notice our 8 has 1 more oxygen than our 8. Now, why is that important? Well, in a normal year, people have to memorize this, right? They don't get open book and open notes on their tests and quizzes. So they don't have their polyatomic ions to look at to remember what they are. So this really kind of provides a way to cheat. Because notice, okay, sulfate's on my helper sheet. Sulfate isn't. But if I remember that sulfite and sulfate are the same and that they have the same atoms, they have the same charge, and that sulfate's going to have 1 more oxygen, I can kind of cheat. And I can use my helper sheet to figure out what sulfate is if I've forgotten. Now, you're in an extraordinary year where you get open book and open notes on tests and quizzes. So this might not be quite as important to you, okay? What is important to you is that you understand how to read this, because invariably some people struggle, right? These are kind of dividing lines. Dihydrogen phosphate, hydrogen sulfate, right? Those are the formulas. Hydrogen carbonate, it's right there. Nitrite is right there, okay? So there's kind of 3 columns, if you will, of polyatomic ions here. So that brings us to the end of our notes. Your homework assignment is on page 148, questions 20 through 23. Have a great day. I'll talk to you tomorrow.